Hello everyone, this is Plavita and today in this video I'll be explaining my project assignment on foundation design that I have completed through Skyfi Labs. Now let us take a look at the problem statement. Here we have to consider a safe bearing capacity of 300 kN per meter square and an allowable settlement of 1 centimeter. The table displayed shows the dimensions, dead and live load, and the materials of the columns. Here the columns C6, C7, C10 and C11 has a dimension of 600 into 600 millimeters and all the other columns has a dimension of 500 into 500 millimeters. Now let us calculate the subgrade modulus. The subgrade modulus is equal to the safe bearing capacity divided by the allowable settlement. Here, the safe bearing capacity is equal to 300 kN per meter square and the allowable settlement is 1 centimeter. Hence, the subgrade modulus comes out to be 3 into 10 to the power 4 kN per meter cube. The base slab is 18 meters in both x and y direction. So considering 18 meters, the design strip width comes out to be 4.5 meters. Since there is no provision for considering the strip width, we can allow a lesser value of 4 meters. Now the plan shown is the plan of the footing. The footing underneath will be extended in all sides to cover the corner columns. Let us extend the mat by 2 meters on all sides. Hence, the length of the mat on all sides becomes 22 meters. Now let us proceed forward for designing the footing in the SAFE software. First of all, open the SAFE software. After opening the SAFE software, select New Model from the File menu. We can see the New Model Initialization dialog box has appeared. Now we'll change the design code to IS 456-2000 and check if the default units is metric. If the default units is not metric, then we'll change it to metric by clicking on Modify/Show. Now in the design preferences, we'll change the clear cover to 50 millimeters for both top and bottom. We'll take a preferred bar size of 22 millimeters, then we'll click on OK. Then we'll select the grid only option. We will first draw the slab of the building, then we'll extend it equally on all sides. In our case, the slab is of 18 by 18 meters, thus with 1 meter spacing grid lines, we will need 19 grid lines for x and y direction. Hence, the number of grid lines is in both x and y direction is 19 and the grid spacing is 1 meter. We can see that a grid of 18 by 18 meters has been formed. Now we'll have to define the properties. First of all, we'll define the materials by clicking on materials from the define menu. We'll have to define two materials, one M40 concrete and the other HYSD 500 bars. First, we'll define the M40 concrete by entering the standard values. Now we can see that the M40 concrete has been defined. Similarly, we'll define the HYSD bar. We have defined both the materials. Now we'll define the slab property. We'll name the slab as mat footing. We'll define the slab material as M40 and the slab type as mat. Initially, we'll consider a thickness of 500 millimeters. After defining the slab property, we'll define the column properties. There are 16 columns in the mat, but there is only 2 different columns. So we'll have to define only 2 columns. So we will add one column with dimension 500 by 500 and the other with dimension 600 by 600. Similarly, we'll define the other column. After defining the column properties, we'll define the soil subgrade property. In our case, the soil subgrade modulus is 3 into 10 to the power 4 kilonewton per meter cube. So we'll enter the value as 3E plus 4. We'll check the load pattern and the load cases. After checking the load pattern and the load cases, we'll define the 2 load combinations. We'll define one load combination for the ultimate load. While defining the load combination for ultimate load, we'll enter the scale factor as 1.5 and then we'll select the strength ultimate option. Now we'll be defining another load combination for the service load. For this combination, we'll enter the scale factor as 1 and then we'll select the options service initial, service normal and the service long-term option. Then we'll click on OK. Now we have defined both the combinations. Now we have defined all the required properties, so we'll start drawing the footing. First, we'll draw the slab. For that, we'll have to go to the Draw menu and select the option Draw Slab/Area. Make sure that the property selected is mat footing. Now we'll draw the slab. First, we'll click on one corner of the grid and then we'll click on the other, which is 18 meters apart, and then the other. In this way, we will complete the drawing of the slab. After drawing the slab, press Escape. Now we have completed the drawing of the slab. We will expand the slab. For that, we'll have to select the slab area. Then we'll go to Edit. And then we'll select the Edit Area option and then the Expand or Shrink area. Here we'll have to enter the offset values, which is 2 meters, that is 2000 millimeters. We can see the slab has been expanded. Now we'll draw the columns. For that, we'll have to go to the Draw menu and select the Draw Columns option. First, we'll draw the column with dimensions 500 by 500. So, select the property below None and the property above 500 by 500. Then, enter the height below as 0 and the height above as 2 meters. Now we'll draw the columns 6 meters apart. The grid lines will help. Now we'll draw the design strips. We'll have to go to the Draw menu and select the design strip option. The design strip width in our case is 4 meters. So change the values of the strip width to 4 meters in all the directions. Now we'll start drawing the strip layer A in the X direction. Now we have drawn all the elements. So now we'll assign the properties and the loads to the footing. First, we'll assign the soil property. For that, we'll first select the footing area and then verify the selection in the bottom left corner. Then we'll go to the Assign menu. Then we'll go to Support Data and then select the Soil Properties option. Then we'll select the soil property Soil 1 and then we'll click on OK. We can see that the Soil 1 property has been assigned to the soil. Now we'll enter the loads to the column. For that, first we'll have to press Escape to deselect the area of the footing. Then we'll select the first column, then verify the selection that shows 1 point selected in the bottom left corner. Then we'll go to the Assign menu and then enter the loads in the Load Data and the Point Loads option. First we'll assign the dead load, then which is 1850 kilonewton, and then we'll enter the dimensions which is 500 by 500. Then we'll select OK. Again we'll select the same column. Again we'll select the same column . We will first enter the loads for the columns with dimensions 500 by 500 so that we do not have to change the dimensions each time. Now we have completed assigning the loads to the columns. After assigning the loads, we can check it by right-clicking at the point. Now, as we have assigned the loads, we will assign the rebars in the footing. For that, right-click on the footing area and change the rebar material to HYSD 500. We do not need to change the rebar material for columns as it is already changed with respect to the footing. Now we will assign the rebar material to the strip For that, we will first right-click on the strip, then change the rebar material to HYSD 500. In the same way, we'll assign the rebar materials to all the strips. Now, we have completed assigning the properties. Now we will run analysis to the footing. For that, we'll have to go to the Run menu and then click on Run Analysis. When the analysis is completed, we can see the displacement value of different regions. Now, we'll again go to the Run menu and this time we'll click on Run Analysis and Design. Then we'll go to the Display menu and then click on Show Punching Shear Design. We can see that all the punching shear ratio are more than 1. So we will have to increase the slab thickness. For that, first we'll have to unlock the model. Then we'll have to go to the Define menu and go to Slab Properties to increase the slab thickness. Let us increase the slab thickness to 1000. Now we'll again have to run Analysis and Design on the footing. Then we'll have to go to the Display menu and select Show Punching Shear Design. Even after increasing the slab thickness, we can see that the punching shear ratio for some of the columns are more than 1. So we'll again have to change the slab thickness. First, we'll have to unlock the model. Then we'll have to go to the Define menu to change the slab thickness. This time, let us increase the slab thickness to 1200 millimeters. After increasing the slab thickness, we'll again have to go to the Run menu and then click on Run Analysis and Design. Then we'll have to go to the display menu and click on Show Punching Shear Design. This time we can see that all the punching shear ratios are less than 1. So, this is the final design of the footing under which the design check has passed. So now we can use the slab with properties for construction. Now let us take a look at the 3D view of the footing. So we'll have to click on the Set Display option and then select the Extrude View option. Then we'll have to click on OK. Then we'll have to click on the 3D view option. This is the 3D view of the footing we have designed. Now let us interpret the results. For that, we'll have to select the XY plane view and then select the Extrude View option. Now, to interpret the results, first we'll have to go to the display menu and then select on Show Strip Forces option. Here we can see that the moment or force for the selected load combination along the design strips. Now, click on Apply. To see the values for the different layers. Now we'll close this dialog box. Now let us see the slab design. For that, select the slab design option from the display menu. Now we'll mark the imposed minimum reinforcement option. And then we'll click on Apply and close the dialog box. The top and bottom reinforcement intensity for different layer is being displayed. Now let us see the result for the design strip in the same procedure. Now let us select the Show Slab Forces / Stress option. We can select any particular combination and any particular component to see the corresponding result. Let us see the result for maximum moment. Similarly, we can see the results for the other components and the load combinations. Let us see the crack widths now. Select the Show Crack Width option from the display menu. We can select any load combination. Let us select crack location as the slab bottom face and apply. Now, we can see the various crack widths. Different color represents different crack widths. Now, let us see the details. Go to the Run menu and click on Run Detailing. We will have to select all the options and then click on OK. The reinforcement diameter plan is being generated. Now expand the Drawing Components option and then expand the Slab View option. Now double click on the rebar table. We can see the bar dimensions, length and number of each bar size. Similarly, select the bar schedule and the bill of quantities to see the following result. The bill of quantities shows the quantity of the rebar used. This is the rebar schedule. Now the bill of quantities has been displayed with the bar size and the length of the bars. Now let us expand the individual slab view and then expand the Mat 1 option. The rebar plan expands the plan of the rebars all along the mat. The reinforcement profile option displays the reinforcement distribution all along the different strip layers. The section 1 and 2 option displays the rebar plan and the elevation in both X and Y direction. In this way, we can select the other options and see the other rebar plan in different forms. Now we have successfully completed the project. Thank you for watching.